Right. The next kind of special function we're going to talk about is something called the step function. And the idea behind a step function is it is some sort of graph that looks. Oh, I'm drawing this behind my picture there. It's some sort of graph that looks like it's made from a bunch of steps. So it has some sort of pattern, and sometimes it might have the open dot on the left or the open dot on the right. It might be longer than 1 unit, but the steps shouldn't ever overlap. Just like if it's supposed to be a function, they shouldn't overlap. Just like if you were walking up some stairs at someone's house and there was a step a couple pieces up that was above the step that you're trying to step onto now, it'd be all kinds of weird and confusing. Something you'd see in the Winchester mansion, I'm sure. The most common or like basic form of this is a particular one called the greatest integer function. And we use these weird double brackets here around the x, and that represents the greatest integer function. You can see it's so common that it's even available inside this program I'm using to type out. So it's out there. It's a thing. Spreadsheets do it. Even your calculators can do it as well. At least I know this guy can. This guy probably can. I just have never used it on this because it's really easy to figure out. Basically, all it is what was the greatest integer less than or equal to x? So, for example, let's say you have an x value of 5.4. Well, think of it. Just drop all the decimals off. You got a 5. Now, it's a little bit different for a negative value. Like if you had negative 5.4, if you think about this on the number line, and I'll kind of draw on a zoomed in number line here. Negative 6, 1, 2, 3, 4, 5. So this is negative 5.5. 1, 2, 3, 4. Negative 5. So if I were to plot negative 5.4 on a number line, negative 5.4, think as you're coming from the left, what is the last integer you run into before you get to that point? And you can see it's negative 6. So the step function here for negative 5.4 is going to be negative 6. So you just think about, look one down on the number line, find the next integer down. That's your greatest integer function. So it's basically saying, what's the greatest integer before you get to whatever number you have. All right. Now, that seems like a kind of an odd function to have, but it actually has some real life application. When you go to like a automotive repair shop, or you call someone to come and fix your AC, they charge you just for coming out, and then they charge you by the hour, and they don't charge you partial hours. If it takes them 3 hours and 5 minutes, they charge you for 4 hours. Well, the nice ones will charge you for 3 hours, but some of them will charge you for 4 hours, right? So the whole idea is if you just use part of their hour, they're charging you for the whole thing. And part of that is otherwise they're like figuring out slight little different calculations, and that error allows them to drive around and get to the next job site. They also use it as a prediction for the cost. So if you get a quote like, how long is it going to take to fix my AC? They look up what's wrong with it, and the computer says, hey, it should take 3 hours to fix. So then they quote you 3 hours. So if they actually finish it in 3 hours and 15 minutes, they quoted you for 3 hours, and that's what you pay. So that's where these kinds of things come in. And we're actually going to look at an automotive repair center that charges $50 for any part of the first hour of labor. So if they look at it and go, yep, your battery's unplugged, they charge you $50. And that's a real thing. Some places will charge you $150 just to look at it and say you're out of gas. And then $35 for any part of each additional hour. Draw a graph that represents the situation. So let's make a little table of values here. What if they do, so we'll have X, and then we'll have this function here, f of x. We don't really have a way to write it out, but we're just going to use the description here. 35 for any part in each additional hour, $50 for the first hour. So let's say you show up, they charge you, they open up your car and go, yes, your battery is on, the cable's off. Takes them 3 minutes to take a look at it. So that would be 5 minutes to take a look at it. So 5 divided by 60 is so basically 0.08 of an hour. Well, how much is that going to cost? That's going to cost $50. What about if they spend half an hour trying to figure out what's wrong? Well, that's going to cost $50. What if they look at it for 0.9 of an hour? That's going to cost $50. And if they look at it for exactly 1 hour, $50. Pretty boring table of values so far, right? Now, what if they look at it for an hour and a half? So 1.5 hours. Well, now here's where they add in their $35, right? So there it's going to be $85. Where if they look at it 1.9 hours, it's almost at the 2 hour mark. They're still going to charge you $85. So the idea is, for that whole range for the second hour, it's just $35 extra. They're not going to like prorate you, is what it's called, for the amount of time they actually spent. All right. So that's the idea here. Now, if we do it for exactly 2 hours, what happens? Well, that's for each part of the additional hour still in that, so it's still going to be 85. But as soon as you get up to 2.1, so an hour and 12 minutes, they add in another $35. So now it's $120. So you kind of see the pattern here. So let's draw out our graph. And I'm going to set this up so we have hours on the bottom, and I'm going to double it so I can kind of see what's going on here. So we got 1 hour, 2 hours, 3 hours, 4. That should give us enough of a visual of what's going on. And so this is hours. And so it goes up to 120. So let's go by $20. 20, 40, 60, 80, $100, 120, 140, and up here that'd be 160, right? So dollars. All right. So if you go to the store or to this automotive repair shop, they're going to start charging you money, right? But if you don't go, let me actually draw these points here in red. You're not going to get charged anything. If you spend 0 time there, they're not sending you a bill. But as we saw when you took a look at it here, all the way up through 1, it was going to they were going to charge us $50, right? So I go up, that's 40, so 50. So let's do, and if you spend just 1 minute there, they are going to charge you $50. So let's make that a solid line there across. And let me double check the book. Sometimes it's difficult to make sure you know where the hole is. And I'm pretty sure I got this right here. I'm just going to double check that I do. I messed this up last year, so I want to make sure I get it right this time. I had to make a whole meme with it. Oh, no, I was right before. When I had this red dot on the bottom. Dang it, I should have trusted myself. Oh, man. All right. So if you spend 0 time there, it costs you $0. But as soon as you start spending time there, it's going to cost you $50. all the way up until 1 hour. But as soon as it gets into the second hour at all, it's going to cost you $85, which is right here. So all the way to the second, and then a solid dot. And then if you're there for more than 2 hours, it's going to cost you $120. So we'll do open dot there, all the way over to the 3, close dot. And now we go up another $35, so $155 for the third hour. And for the fourth hour, it'd be up again. So there's your step function, right? And if you get confused on where the holes are supposed to be and where the solid parts are supposed to be, just think about what the like the 0, would be, or think about what it means, the difference here. Like if you set a timer and they finish right as you ding, they're not going to charge you up to the second level there, right? So that's how we know that it's a solid dot goes with the hour. All right, so there's a graph of a step function.